So, hi guys, here we are here to discuss Spring Security Architecture today, and I would be doing code on the next session. So, I hope you guys understand the architecture from this because eventually it is going to help you connect to a lot of other services. Because Spring Security is not just implemented as a web security or an application level security, it has multiple levels to it. It can connect to other services too. So, let's get started with the session now. So let's go with what is Spring Security. As last sessions we have had, there was uh, data right. We were just implementing databases, correct? Where we were just fetching data and showing it on the front end. Now we understand completely any website that we go to, correct? So we go to any other website any day. We have to log in, right? Anybody should not have the access of our data. So how do we control that access? How do we know who is accessing the data? For that, we need the security. And Spring Security is just a library like Spring Boot Starter. We have another library called Spring Security. Okay, it is a set of libraries that comes under the starter tablet. Here you will have authentication and authorization combined into one library. Now there is a difference between authentication and authorization. Okay, authentication means who I am. Right, when I try to log in into Google or I try to log into Facebook, they need to know who is the one logging in. Okay, is it me, is it somebody else? So we do that by using password systems, and there is a full implementation of OAuth, which we will cover eventually as we go through with this section of the course. Now, going to the next section, there is authorization. Authorization does not deal with the identity. It does not tell who is accessing the system. It just says there is a token generated in authentication. Whoever has this token, the identity, is he allowed to access a certain resource? Think of it as a pass, okay, a ticket that you get when you do a book my show ticket, okay? When you are trying to book through book my show, you buy a ticket, they know who bought the ticket. Okay, then you can gift it to anybody, your friends, your girlfriend, your family, anybody else. That token does not say who bought it. Okay, you go to the entrance and you show them and they allow you inside. That is what you call as authorization. Okay, and Spring Security library deals with both of these, and if we have to do these coding ourselves, you understand, every website link you have to design a login page, have to design the database, you have to check on every object that you want access to whether this has authorization or not. Every URL that you open, it has to be implemented by yourself and check every single time if this is working or not. All of these things, why do we need to do? Now there are cyber security concerns. Tomorrow, let's say there's a patch fix, a new bug is found in ww framework itself, some network bug. Who's going to fix it? We are not, as the developers, right? We are not well aware of all these things, but cybersecurity developers are quite well aware, so they maintain all this so that we don't have to worry with this hassle. So what is the features of Spring Security? Exactly. Authentication, authorization, access control. We have method security. Now it means, let's say there's an application and you want to share a web page. Okay, you share a Word document. You have right now you have right, can view, can edit access. This is called method security. How do you know if somebody is allowed to do some kind of editing while some other admin is allowed to do everything? He can even delete. Delete is a different method. Update is a different method. We call it a put method. Post is just we can send a new data. How do we implement this kind of security? The user is allowed to log in, okay, but how much control has he over calling certain methods? That is called method security. Web security, now we have various levels: CORS, CSRF, and now how we store password. There used to be MD5. Okay, plain text. Some people just used to do plain text. Your password is saved as data in plain text in database. Anybody could just hack and see it. Then came MD5, which had a security loophole. Finally, there was SHA-256 hashing. Okay, we would hash and keep the passwords in the backend. But there was again a problem. Another loophole was found that for the same message, you can have two different hash keys. So again, it's possible to generate two separate hash keys, and this is a bug. So finally, bcrypt was mentioned. Now who's going to implement bcrypt? We will, and no. Spring Security comes with the library that allows you to implement all these kind of encryptions. It's when I say highly configurable, it means that you can configure what level of configuration you want. Do you want the user to be present in the database on some cloud environment? Do you want it to connect to some third party? Do you want a full method security or class level security? Certain class a user should not access, certain objects he cannot create, these kind of access, and this all this configuration can easily be done with annotations in Spring Boot. Now finally, it can be customized with a third party IAM tool. Now recently, if you're working in Node.js, you might have heard about Okta Passport, right? Then in recent trend, I've also heard about Keycloak. Keycloak is a third party authentication tool, right? Authentication and authorization. It covers all of this in a third party tool. You log into Keycloak, it sends you authentication token and authorization token that you can verify with Spring Security. So your authentication and authorization can be done either with Spring Security or with a third party tool, or you can even connect, you want to connect to, let's say, Google. Okay, you need Google Drive, Google Cloud. Okay, but there is a data that other user has, so you have to log in, right? This is called third party authorization. Spring can allow you to configure and log in with Google also. This kind of configuration is allowed with Spring Security. Now we have active directories. If you are working in an organization, you realize, right, you have the same username and password, both for your internal systems, correct? And for the full website itself. If you want to fill in your timesheets, etc. All of these things, right? You want to go update your attendance on the website. It is exposed to the foreign to the internet. You can access them directly from the internet, but when you try to log into your own system, right, you have the same password. The database you try to log into of the company, you might have the same password. So these are two different kinds of authentication, right? This is called through active directory authentication. So this kind of configuration can also be attached with Spring Security. Now, before going with Spring Security, right, we will go with the key terms of the architecture. Okay, Spring Security uses three important factors to run authentication. One of them is Authentication Manager. It is an interface that supports one authenticate method. Now understand, this is an interface and not a class. Okay, you have to implement this interface. The interface takes in an authentication object, okay, which has a method called authenticate, which can be returned true or false, and there can be a null. The object itself can be null. So it throws an authentication exception, which is a runtime exception. It should be very clear. You don't throw it automatically. If there is no authentication find, a null is thrown, and the front end handles like 401 unauthorized, unauthenticated. Sorry, 403 is forbidden. So the error will be sent as 401, and the browser will convert it to authentication failed. But the answer here on the backend will be null. We have provider manager. As I told you, this section is an interface. So authentication manager needs to be implemented. Who is implements it? It is done by provider manager. Provider manager supports an multiple authentication providers. Okay, like let's say you want to do LDAP authentication. Okay, and then you want to also try Keycloak together with it. Correct. These are two separate authentications. But when you log in password, right, you don't mind. Let's say you're logging into a company. You can log in through username. Okay. You can also log in through your email ID. Correct. And you don't know which method you are using to log in. Okay. There might be possible that they're allowing you to log in through phone number and OTP. Now understand this. These are three different mechanisms to log in. You are logging into the same website. You are getting authenticated. But who's verifying it is a different process itself. Okay, so this provider manager can have different kind of authentication providers that will allow you to uh, authenticate with different systems, so that if you use one kind of method, right, you say OTP want I want, so that authentication provider will be used. So provider manager works quite well with authentication provider. It is also like an authentication manager, which has an authenticate method, but this one has one extra method. This is also an interface that you need to implement. It has the extra method called supports. That means, does it support LDAP authentication? Does it support email authentication? Let's say, does it support OTP authentication? So if you try to log in and certain facility is right, certain username is not available, allowed to support this kind of authentication, then this will be disabled for the user. So this is how we control authentication provider. All of these combined give Spring Security the ability to complete authentication. We are not talking about authorization yet. This is just to know who is the one logging in. So this is the structure which I picked up from the Spring Security itself. This is the interface, but you can control click on the these providers on the IDE and you will still get them. See, as you can see, this is a public interface authentication provider, correct? And then there is authentication manager. So as you can see in the manager, there is just one method, authentication, authenticate, and it throws an authentication exception. Okay, but notice authentication provider has two of them. Okay, it has one authenticate method and one of them is supports method. So supports will tell you whether it supports them this kind of authentication or not, and there will be multiple authentication providers. Okay, there will be a provider manager at the top, and on the bottom there will be multiple authentication providers, and they will tell if I support this kind of. So provider manager will ask, do you support this kind of authentication? So provider manager will ask its implementations. One of the implementation will do an or, one of the implementation will return, yeah, I support it. Okay, I support it. So that means the provider manager supports it. So you support certain kind like this. This is the full architecture for Spring Security. Now here you see there's an authentication manager on the left hand, right? That is implemented by provider manager, and we have authentication providers. We will talk about filters a bit later. That is about how Spring Security actually implements this security itself. We are talking about the architecture inside the Spring Security. Now we have access decision manager. Okay, this is responsible for authorization. Config attribute allows us to configure which resource needs to be protected. This is a annotation. This is an object, right, that allows you to tell, okay, this is the object that I need to protect. Okay, the authentication will be implemented on this object, or the authorization will be implemented on this object. So we will talk about a bit about authorization now. As we told, after authentication manager is configured, now the next step is Spring knows who you are. Okay, in the security context, right, a session is built. You have been given a JWT token in the front, session token. You go to the front end and then you make another request, or maybe through Postman or through another service, you make a request. So what you receive after an authentication is an authorization or access token. You need to send that access token back to the backend. Okay, then Spring Security will check the token. Okay, if this token has a certain kind of access, let's say the token you logged in as admin user, you authenticated, right? On top of it, it will send you back a token. It will be a JWT token that will contain, when you decrypt it, right, you will find that there is messages like how long is the session valid. Okay, how when will the session end, when was the token created, is they might send a refresh token for you to refresh the authorization duration. Okay, but apart from that, it will also have what roles do you have, what privileges do you have if you have configured them. So with that, when it verifies that the token that you have provided, right, then only then will it check if the role is implemented or not. How does it do that? How does it implement authorization? For that, we have something called as access decision manager. Think of it as a parallel to authentication manager. Authentication manager supports authenticate, right? Access decision manager have access decision voters that you implement. Okay, each voter returns either true, false. Okay, it will return an int value 0, 1. Okay, so we can have multiple access decision voters. Okay, let's say I have 5 methods. Okay, create, update, view, okay, delete. Fine. Now, each of this is a separate role. Let's say admin is allowed all the 5 roles, okay? But as you log in as a user, you are not allowed all of these features. So what happens is we ask access decision manager, is edit allowed? So the access manager decision manager responsible for edit will be no, edit is not allowed. And that's how they decide how much privilege do you have. Is the user allowed to create? Oh yeah, he is allowed to create. Is he allowed to view? The access decision voter for it will be like, yes, it's allowed to view. So you can have different level of configuration. Do you want a mixed vote or do you want a or vote? Okay, let's say you have the authorization, right, is provided by LDAP but not provided by Keyclock. Okay, so we can have mix and match. Is it an and or is it an or? By default, think of it as a jury. Okay, we have a judge at the top, which is access decision manager. There is an access decision voter on the bottom. There's a jury of 7 people. Okay, but here the system is, even if one people general by default, even if one person majority says or one person says you are allowed access to a certain resource, then you are allowed. You can change this. Okay, that let's say there are 7 access decision voter and more than 50% is says yes, only then there will be a yes. So this is how we implement authorization using that. Now we have config attribute. We use this annotation over objects. Okay, I will be showing in the further sessions how to configure all of these later on using coding. How are we securing config attribute? How are we doing web security? Okay, so when we go to config attribute, it takes in an object. Okay, the class is a question mark template class. It takes in an object, and with through that you can configure if certain kind of role or role is allowed to access a certain resource. Let's say you have a class, okay, repository object, that you try to access to and create new data. Okay, you want to import. Let's say you send some data. Let's say you have created an application for ticketing system. Okay, you're trying to book, you filled in the details. Now you have to create ticket ID and all, right? Let's just say, okay, when you try to click create, right, an instance of the repository will be created, correct? One object will be created for the model interface. The model will, but now I'm saying this role is not allowed create. So what will happen is, before going to trying to create an object, right, it will try to call configure attribute and ask access decision managers, is this user allowed to even create this object? They will say no. So you will get a authorization exception, and then the object itself will not be created. This is how it controls the, but this is not method level authentication. Now method level is, there is service class. Okay, we create, as I told you last time, we had a controller, we had interfaces, right? In the repository we had model classes, and we had service where our original logic was. So on the service, right, let's say for create we have one method, for edit we have another method, when we call put we call another method in the service, when we try to delete we call another method in the service. So each level of method we can control with at the rate secured annotation. Okay, and in that annotation we'll provide a role admin, a role user. That means, is this role allowed to call this method or not? So let's say admin will be allowed to do all of these things. Okay, so secured will contain one role. Role admin will be there everywhere, but role user will be missing from certain of them. Like delete, a user is not allowed to delete. So when the controller tries to call a method from the service for delete, it will again throw an authorization exception. You are not allowed to do it. The method itself you cannot call. So that is how we configure authorization in Spring Security. The thing is, with authentication manager and access decision manager, this is inside Spring Security. But now this is the beauty of Spring Security. If you have a third party IAM tool, as I told you, Keyclock and Pass Okta, right, or any other Kerberos authentication, what happens is you don't perform the authentication. Okay, what you receive is an authentication object or exception, null. You don't even have the access decision manager. Okay, it's an interface. The access decision voter is implemented actually inside the third party tool. They will decide if you are allowed to access certain things or not, and then they will give you a decision. The combined decision will go to the manager. The manager on the your local host will decide, okay, on your Spring Security, the backend will decide. It will ask for vote. The vote call will go to the third party tool. The third party will do the voting and check for the resource accesses, and then will, with the token, then it will tell you back, okay, this user is allowed or not allowed to do certain things. And then the manager will give an exception or allow you the access. This is how it works in Spring Security. So this kind of config, now tomorrow you want to do with Google authentication or Google authorization, or you want to implement OAuth 2 with Google authentication. So all of these things, is it it's possible because Google will realize, right? Google has provided you an authorization token, right? You on the back end cannot verify it. You cannot even check the authentication. So what you do is you have a manager on your back end, but the provider manager, right? It's implemented by the Google. You create an object of that. And then what you do is these provider managers send a REST API call to the Google authentication server and tell them, please authenticate these deals for me. What Google will do, it will send you an authentication object or an exception. And that's how you know. Then the manager will throw you an exception or not, depending if you're allowed or not. So this is the configurability of Spring Security. Now, you are not writing the REST API call to connect to third-party service. What you do is all these third-party tools, they provide you a security adapter. Adapter is nothing but a new class. Okay. These adapters allow you to configure the port numbers, the URL addresses of these third-party tools, the username and password needed to log in. And then you log into those websites, get a token, validate them there, then they return you the result. And what happens is all of these managers, right? They take a culmination of that result and then give you the answer. That is why there is a difference between manager and provider manager. This is why these are an interface, so that either you can implement it locally for application security. Okay. What I mean is you're developing a backend application that is not a web application tomorrow. Okay. User is trying to log in here on my desktop. It's trying to access another desktop, but no web API is exposed. Okay. This is then what you do is you implement authentication and authorization yourself. At that case, you have that permission. What you do is you create your own, usually default voters work, but you create your own provider managers. You create your own access decision voters. But when you are accessing a third party tool, these bottom layers, these are implemented, right? Even the secured resource, the resource securing is done by the third party tool. They will just tell you the result of the authentication or access decision, and then you take that result and decide if you are allowed to cut certain method or not. Now CAS is, these are all different kind of DAO authentication provider. LDAP is Active Directories. We have CAS as Central Authentication Service. That is what Keycloak and Passport are those. Now finally go with how does it implement web security or any other kind of security. So now let's say client. Here client represents front end. Front end means your web page. It can mean an Angular application. It can mean a React application. It can even mean Svelte or any other application, let's say Vue.js or none of these. Okay. You created a separate JSP pages. Okay. That's running on a different server. It's trying to call a backend service. So what happens is in security, web security uses security filters. Any call going to the controller first has to pass through filters, which is by default disabled. The moment you implement Spring Security, the moment you just add the import, okay, just the import, you have to do nothing. You just add a dependency, all of these filters become active. Let's say the first filter receives HTTP request, okay? Filters have the ability to intercept requests, modify them, change headers. It can even remove authentication from them. It can change the token. It can verify the token at that level. So what will happen is the filters are the one that contain the code. Let's say you're getting an HTTP request, GET request. Okay. Now, what they need to check is you have received an authorization token. At the filter level itself, they will check if you are authenticated or not. So the filter will call the third party service, the security. That what it will do is it will check, okay, is this user even allowed, is authenticated or not. It will take the token, pass it to Google Auth, or if you have implemented it yourself, it will pass it to your own provider manager. The provider manager will verify it. Yes, this user is authenticated. Then filter takes it and then sends the result to servlet. But there's a section now. Let's say you have home controller, but you are not authenticated. The request will never even reach the controller. That's how these filters work. And the filters can go down and it can intercept requests while going down or coming up. So there are things like while receiving a request, you want to edit the headers, or while sending the response back, okay, you want to attach an extra header, okay. All of these things are done at the filter level. Now, let's talk about CORS a bit. CORS is cross origin scripting, okay, resource sharing. Now let's go here. How does browser tell you, how do you avoid from calling scripts from one browser page to another browser page? How does it know that two pages are separate? You are not on the same domain. So what browser checks is your URL address, okay, localhost, then or any other google.com. Then there is a port number after that. If it's HTTP, it's 80, okay? It's 8081 for sorry, it's 420 for HTTPS. So if it's HTTPS, the port number is auto implemented. But now let's see your backend, right? You wrote a Spring application. It's running on port 8080. Your front end, you wrote Angular. It's running on port 7000. You are both running on localhost, maybe the same domain, but the port number is different. So when you try to call the backend service, right, this is called a cross origin. The domain does not completely match. You're trying to make a GET request to a backend service, but browser will just check. Browser makes two requests. It will throw one request which is called an options. There are different kinds of HTTP method: get, put, delete, sorry, fetch, post, right? There's an options method. With options, it actually asks your backend application, what kind of headers do you want? Though, so what will happen is the backend sends you a list of headers, right? Yeah, I allow certain URLs to access my backend service. Okay, and you need to send me those URLs. So cross origin needs to be actually allowed from the backend. What is this called? This is called a CORS filter. Okay, back until and unless backend does not allow you, the browser will not even send a request to the backend, to your server. It will block your request. It will send an options request. Options will directly say that I do not allow cross origin. So a client cannot call my code. So the code will never even reach to the security filter. The browser will block it. And this is a how do you configure these things? All this web security, right? These are all classes and libraries available inside Spring Security. And this is how Spring Security implements web security. We will go ahead later on and show you in further sessions, right, how to configure web security, how to work with role, right, admin role, user role, how to work with method securing. That means how can I disable if admin is allowed to create certain things while a user is only allowed to view, or maybe let's say in a company there are various levels of permission, right? You are allowed access to certain pages, you are not allowed access to certain pages. So in this all of these feature, how does a third party come in? So security is not actually a feature that you need. It's a separate domain. Okay, it does not have to come with your application. See, security is not just needed at the back end. Let's say on the front end itself, okay, you don't want certain buttons to be clicked, okay, but you want certain other buttons to be able to be clicked if the user is admin, if the user is user. It's a just basic user with basic privileges. The edit button itself should be disabled. So what you need? You need an authorization, right? You need a token. You need the role. User has a role, right? Whether he's allowed the edit role or not. So what we do is we implement a third party security application, and client communicates to the third party. Okay. And then it just takes in the role. And what backend does is backend does the same thing. Client sends it's a token. Okay. Spring Security sends that token to the third party and verifies if it's again allowed certain roles or not, and then implements the security according to the configuration present in the third party library. And this is actually, guys, how enterprise works. Because no, who wants to write a complete IAM tool separately, right? But many companies, just for their own, like, if you want to completely insource it, right, you want to make it in-house, Spring Security allows that, and many companies do that also. But with the rise of third party tool and services, right, the development time is increasing very fast. Or else what you will have to do, you will have to write the full security application yourself, and then that security needs to be updated by your own team. So there are companies that build product for security. Spring Security can easily connect with them with easy configurations in application properties. And there are security adapters provided by these companies to be able to configure with the web security. So these things we will show you. I will be doing key clock as I've been experiencing that, right? I'll be showing you how to do these things with key clock. And I believe this is all we have for today. I hope you understand the architecture a bit. The details will become clear, right? This just gives you an overview of the flow of security. What happens when a user tries to authenticate? So I'll tell you what happens. Login comes to the Spring Security Authentication Provider, right? Authentication Manager, sorry, my bad. It goes to Provider Manager. Provider Manager has multiple implementations. It authenticates you or returns an exception. If it authenticates you, then you are logged in and you just try to call services. But any of those services, right, if they have config attributes or if they have method level authentication with @secure tag, then these decisions go to Access Decision Manager, who checks for roles. Okay, these roles, correct, these roles then needs to be checked with the annotation you provided. Do the roles match? If they match, the service is called. If they don't match, correct, then you are not even allowed to call those methods, and the authorization fails and you get an forbidden exception, that is 403 in the front end. If you get 401, that's unauthenticated. That means you are not do not have a valid token to log in. So companies vary. Okay, sometimes if you just implement authentication and authorization in the front end, you disable certain buttons, but you don't disable it in the back end. Any third party user, right, they can just run a Postman tool and overload your API. They can just perform a DDoS attack because you're not even verifying authorization. If they somehow get an authentication token in the token from the front end, they hack that token. They can just keep sending you that token and they can hack your service. They can DDoS attack you. So what you do is you start blocking these sessions. They are not even allowed to do those, fetch those kind of data by directly calling your APIs through tools like Insomnia or Postman or any other third-party tools. Because understand, CORS is blocked by the browser. So if browser does not implement the blocking of CORS, Postman does not, Insomnia does not, there is no options thing. It's the responsibility of the browser to block CORS. The backend does not block CORS. Backend tells an options what is allowed. Browser takes those options and decides if I should block a request or not. That's it. Backend will never block for CORS. So when Postman does it, right, the request goes. Backend does not care because the Postman didn't block CORS. The backend does not care. It will allow you with the token. You just made a cross-site request, and then since you did not implement authorization in the backend and you were reliant on the front end on the client side, just your data is exposed. So be very clear when you are implementing these situations in applications. This is the flow, and I hope, and this is the end of my session for today. I hope I didn't bore you guys. maybe give me some reviews if you want something else, or the sessions to be better, or how I could explain these architectures better. Next sessions, I will actually show you how to do live coding and configure a third-party tool Keycloak with this. So that with Keycloak, we will be able to secure both front-end and back-end and secure certain resources. So folks, that's it for today. Bye. And please leave reviews and comments on this page. Bye bye.